We're back. Determine whether the random variable is discrete or continuous. In each case, state the possible values. So continuous, discrete just means there's just a few values that are possible, finite number or countable number. Continuous means the kinds of values you get are associated with an interval of the real line. Number of free throws attempts before the first shot is made. So that's going to be before the first shot is made. I guess so the answer to that is 0, 1, 2, 3. How many free throws are you allowed? Depends, doesn't it? What's the maximum?
3.
3? So there's my outcomes. You might have made the first shot attempts before. So could you have made 3? I guess you could have made 3 attempts and none of them get made. I don't know what that means then. Oh, before the, I guess that's okay. So that would be called discrete because I can make a list. If you can make a list like that with commas in between, it's discrete. Time required to download a file from the internet. I'm thinking that's like in seconds. In maybe seconds, maybe. Maybe it's an interval. What do you think the fastest time would be? 1/10 of a second, maybe? Less? What's a quick download? Oh, who cares? Okay, 1/10 of a second, I'm gonna go like that. And then possibly, it could take an hour, right? It could be a huge number. I don't know what to put. Maybe 6,000 seconds. I think I'd give up way before that. And the idea is that's an interval, any real number in an interval. And that makes it continuous. All right. In a game of roulette, a player can place a $5 bet on number 9 and have a 1/38th probability of winning. That is true. If the metal ball lands on 9, the player gets to keep the $5 and play the game, paid to play the game, and the player is awarded an additional 175. Otherwise, the player is awarded nothing, and the casino takes the player's $5. What's the expected value of the game to the player? I guess this doesn't belong here. The expected value of the game. So I think expected value is just winnings. So it's x times p of x. X equals winnings. So I get 175 times 1/38 plus 0 times 37/38, like that. So all I get is 175/38, which is 4.6 something, maybe 4.61, like that, nearest cent. So on average, each spin of the wheel would get you $4.61. Most of the time it gets you nothing. Every once in a while you get $175. On average you get $4.61. Unfortunately, you're paying $5 to play. So after you get your $5 back though, right? And when you win, you get your $5 back. I don't think they want us to think about that, but I'm thinking about it. So you play a lot. If you play a lot, you lose $5 each game. Maybe that's okay. And then if you play a lot, this is how much you get on average for each play. You're guaranteed to lose $5 for each play. And so if you're losing $5 for every play and you're winning $4.61, you would lose about 39 cents, which would be the $5 minus the $4.61, which is the expected winnings, is 39 cents, like that. So that means you don't want to play roulette. It turns out in gambling, you don't want to play many, many tries because the expected winnings is always less than what you pay to play. So if you're going to go play, you have to go big and go home. Then at least you stand a chance of winning. If you play a long time, you're guaranteed to lose because you're going to converge towards the expected value in terms of your winnings. And you compare that to how much it costs you to play, you're guaranteed to lose. So what you want to do is maybe play 5 times and walk away. Doesn't really help, but once in a while you might win. You don't win that much though, but whatever, that's how it works. Okay. Of course, no one wants to do that. So take all your money. If you want to play, go to Cripple Creek and play. Take your $100, go to the roulette wheel, put it on red, and then when you get 0 or 200 back, you walk away and go home, and you're all excited, I gambled. That'd be the most effective way to do it. If you play a long time, your money just disappears. Number 6, determine the probability, determine if the following probability experiment, it represents a binomial. So binomial says a fixed number of identical experiments, you need that, and they have to result in success or failure. The probability of success, say, is constant, and then you're counting successes. So there's 4 things. Oh, I got independence in there too. Identical independent experiments. So a fixed number of identical independent experiments that result in success or failure. Probability of success is a constant, and you're counting successes. Let's see, here's the experiment here. A random sample of 50 college professors is obtained. So I got a fixed number of identical experiments. Yes, 50. And the individual are asked to state their ages. Is it success or failure? No. Are we counting successes? No. So it doesn't at least, I don't know whether you can even talk about this because we don't have a success or failure. Not binomial. So more or less you have to be doing the same thing over again where either you get a yes or a no answer. So if you ask them, are you eligible for Social Security? There you go. Some will say yes, some will say no. And that could be binomial as long as you counted how many said yes. So that would work. Stopping recording.